In this example, we have two graphs that will graph on the same rectangular coordinate system, and then we'll state the domain and the range. So, first of all, we have f of x is equal to the absolute value of x. And remember, when you have an absolute value function, it's in the shape of a v. So, let's substitute values in for x. If x is equal to -2, then f of x is equal to the absolute value of -2, which is 2. When x is -1, f of x is the absolute value of -1, which is 1. When x is 0, f of x equals the absolute value of 0, or 0. When x is 1, f of x equals the absolute value of 1, which is 1. And when x is 2, f of x equals the absolute value of 2, which is 2. Now I'm going to graph this first function in black. So let's plot these points. -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. And we can see that it is in the shape of a V. So this is the graph of f of x equals the absolute value of x. Now let's compare that to g of x is equal to 1/2 the absolute value of x plus 1 minus 2. Now we have three different transformations going on here. First, I'm going to start with this 1/2. This 1/2 in front of the absolute value of x plus 1 represents a vertical shrink, since 1/2 is less than 1. In other words, each y coordinate will be multiplied by 1/2. It'll be half as large. Next, in red, I'm going to talk about this horizontal shift. This absolute value of x plus 1 is really a horizontal shift, and it's going to be 1 unit to the left, because we have x plus 1 indicates 1 unit to the left. And finally, we have the -2 on the end. I'll indicate that in purple. That is a vertical shift of 2 units down. So that'll be 2 units down. Now I'm going to take each of these 5 points and do the transformation on them in a color-coded way. So let's start with this point over here. -2, 2 was our original point. I'm going to do a vertical shrink. So instead of -2, 2, it's going to go to -2, 1. See, the y coordinate is only half as large. Now I have a shift in the horizontal direction, 1 unit left. So I'm going to take this blue point and I'm going to move it 1 unit left. There it is in red. And finally, this will be my final graph. In purple, I'm going to go 2 units down. So from the red dot, I go 2 units down. This represents my new point, -3, -1. I'm going to do that with each of these other points on the graph. So let's start here with -1, 1. First, I'm going to do the vertical shrink. I'll make it half as large. Then I'm going to make it 1 unit to the left, and then 2 units down. 1, 2, puts me right here. Let's do that again. At 0, 0, if I make that y coordinate half as big, half of 0 is still 0, so it stays right there. Now, I go 1 unit to the left from 0, 0, right here, and I go 2 units down, 1, 2. Here is the first half of that graph. I only need to plot these other 2 points. So with 1, 1, I'll make it, first of all, half as large. That's my vertical shrink. 1 unit to the left is my horizontal shift, and 2 units down in purple is going to be the final point. The last point up there, let's start at 2, 2. Let me move that such that It has a vertical shrink, so my y-coordinate is half as large. My horizontal shift 1 unit to the left, and finally down 2 units, 1, 2. And here is a picture of the graph of g of x. Now that we've done all of our transformations, let's take a look at the graphs again and determine our domain and our range of each function. So our first function that we have in black, f of x is equal to the absolute value of x. For f of x equals the absolute value of x, the domain, we can let x be any real number that we like. And we can see by our arrows on our graph that we can go infinitely in the negative or positive x direction. So the domain is from negative to positive infinity. The range on this function f of x equals the absolute value of x, notice by our graph, the lowest value that we see in the y direction is a value of 0. So our range goes from 0 on the closed interval to positive infinity. So the y values are 0 or greater. Now let's also take a look at the domain and the range of our new function, g of x. So for g of x, here in purple on the graph, I have a domain. Again, for x, I can let x equal any value that I like, any real number. So from negative to positive infinity. And the range, in this case, our lowest point occurs right here. We got that point by starting at the origin. We divided that y-coordinate by 2, which left us at the origin. We moved 1 to the left and down 2. So that y-coordinate is really located at negative 2. And so the range is from negative 2, including negative 2, to positive infinity.